Astronauts do not have an easy time living in space. From the total vacuum outside the space station to the risk of space debris flying at up to 25,000 miles per hour is by no means an easy place to live. But the most hazardous part of the whole trip is re-entry when they return to Earth. NASA astronaut Doug Wheelock described the ride back as like going over Niagara Falls in a barrel, but the barrel's on fire. Intense temperatures and forces on the body of up to 5G, it is a wild ride. How on earth do we engineer something to protect them from all that heat? Today, I'm going to be looking at that through the medium of baking.
That's one small step for man, one giant leap for mankind.
But first of all, what is re-entry? Re-entry is when we come back in from the vacuum of space and slow down as we enter Earth's atmosphere. Slamming into the atmosphere with such force generates lots of heat, both through the compression of the air, generating heat and ionizing the air molecules, and also because of the friction of that air against the spacecraft. So what are the strategies we can use to keep cool? There are three ways we can deal with all this heat. The first one, be blunt. This might not sound so intuitive, but actually by being blunt, it means that when we re-enter the atmosphere, we get a cushion of air in front of the spacecraft. This cushion of air that flows around the spacecraft means that it keeps the surface cooler and it convects away a lot of those hot gases. Traditionally, missiles and high-speed aircraft would be long and slender, but when these re-enter, you get all those hot gases not able to divert in time, and they hit the front and could potentially burn up. So being blunt is key. By doubling the area, we actually halve the heat load on a re-entry vehicle. So the second thing you can do is to choose to ablate your surface. Ablation is just a scientific word for burning off and sacrificing your outer layer of your spacecraft to generate gas to push away those hot gases around the outside. And this is a design decision. You either come in hot and fast for your re-entry and you might want to burn off the material, or you might come in more shallow and use a reusable material. If you're burning away, it's a bit like torching a ginger nut. So as I burn the ginger nut here, you'll see it's giving off gas, in this case carbon dioxide. It's a different gas on the materials we use on, say, the Soyuz. And that protects the center of the ginger nut, or our astronauts, from the intense heat from the blowtorch. So we've made our spacecraft as blunt as possible. We've decided whether to ablate away. What can we do with the remaining heat? Well, we've got to insulate. And you might be surprised to know that air is a fantastic insulator, but only if we're able to trap it in pockets. So the same reason why double glazing insulates your home or why a blanket is warm at night. You've got to keep the air in those pockets. And that is what this thing does. This is a Buran tile. And the Buran was the Russian version of the space shuttle. Although it never went to space, it was engineered to withstand the high temperatures of re-entry. Now this tile is about 95% air by volume, held together with lots of silica fibers, which are an incredible insulator as well. So this thing can take 1600 degrees on one side for over 15 minutes, and it would be lukewarm on the bottom. And I want to compare it with the ginger nut for you. So the center of this blowtorch is about 1400 degrees C, and you'll see my ginger nut doesn't really last very long. The heat spreads and it starts to release gas. By comparison, if I move over to my Buran tile, you'll see it slowly starts to glow, but that glowing spot doesn't move anywhere else in the tile. The heat is contained, and actually, the flame of this blowtorch is a similar temperature to that which it experiences during re-entry. So something else that has a lot of air, surprisingly, is meringue, which is about 80% air by volume. I've just whipped up a little Swiss meringue here. Nice and stiff peaks. And time to show you how good an insulator it is in a classic retro dessert, a baked Alaska. So I've got my sponge insulation on the bottom. I'm just about to pop on my layers of ice cream. So I've opted for a nice chocolate, vanilla, and raspberry sorbet Neapolitan trio. That goes on there. And then straight on top of that is going to go my meringue. So my meringue here acts like the Buran tile that we saw earlier, protecting my precious cargo, my cold ice cream, from the intense heat of the blowtorch, which I'm going to put over the top afterwards. So over my meringue goes, filled with air. It's going to protect my cold ice cream from the harsh heat. And then I'm going to go in with the blowtorch. And that is baked Alaska. Now, the real test is the ice cream still solid on the inside? Let's see if our meringue has done the job. I mean, it's pretty hard to cut, so through we go. And through the... So it's solid, it's so solid, I'm having trouble cutting into it. That's how effective an insulator the meringue is. It's not the prettiest of slices, but that ice cream has not melted at all. And in fact, something you can try really easily at home, pop some meringue in the freezer. So I'm just taking my meringue out of the freezer, and when I taste this, it tastes warm, even though the temperature of that is really low, which is not transferring the heat to my tongue. It's the same reason why a carpeted floor feels warmer than a tiled floor, and it's because of all that air that meringue is such an excellent insulator. It's the same reason why our baked Alaska doesn't melt. It's the same reason why the Buran spacecraft was able to re-enter safely. So there you have it, the surprising engineering connection between how we return astronauts to Earth and a retro dessert. Now, if you'll excuse me. Thanks for sticking around to the end of the video, guys. Hope you really enjoyed it. If you did enjoy it and you want to see more, don't forget to like and subscribe below for loads more content. And if you do want to find out more about FameLab, click that in the link below as well. That's the end of the video.